Welcome to this lecture on process control. We are seeing chapter on first order systems. This is chapter 3, part 4. This chapter and number and part numbers are for sequence and serial numbers, useful for the sequence, for understanding, for following the sequence of the lecture series. This is chapter 3, this first order systems. Chapter 3 is on first order systems. This is part 4 of this chapter. We have seen already part 3, three parts. So in this part, we'll be seeing about step response of first order systems. What happens if you give a step input to a first order systems? When you discuss transfer function, I had explained that transfer function is an indication, is a parameter which helps us to know, to predict the dynamic nature of the system. Given the transfer function, we can predict what will be the transient response, what will be the response of that system for different types of input forcing functions. So now we'll see about giving a step input and what will be the response for that. So before we go into that, I request you once again, request those who have not yet subscribed to this channel to kindly make your subscription. Please hit the subscribe button and subscribe to this channel. MathEnggX. We'll have more lectures on process control and also on numericals for gate. So please subscribe to this channel and also give your comments, criticism, and doubts, everything. Please give your comments in the comment section below and also kindly share to your friends. Well, now we'll go to the topic. The transfer function of any first order system is, k by tau s plus 1. Ys by xs is k by tau s plus 1. K is gain and tau is time constant. Now, when you give a step input, x denominator represents the input and numerator represents the output in terms of deviation variable. Here it is Laplace transform of deviation variables. So, when you give a step input, x of t equal to m into ut, that's step input of magnitude m. How do you find the transfer function? Sorry, how do you find the response? Using Laplace transform. Take Laplace transform of this. So take Laplace transform of this x of t, take Laplace transform, you get x of s and m into ut. Transform of unit step function is 1 by s, and so this is m by s. You substitute m of s into this form. Y of s equal to x into gs, right? Y of s equal to x into gs. If you substitute x of s, you're going to get this. Y of s equal to x into g equal to mk by s into tau s plus 1. Now, if you take inverse of this, inverse Laplace of this, you will get the response equation y of t. How to find the inverse of this? Mk by tau s plus. So the inverse of this can be found by either partial fraction method or by any other method. It has been discussed in detail in one of my previous videos, previous lectures. The link for that is given above as well as in the description below. So if you take inverse of this, you'll get y of t. Y of t, inverse of this is mk. The inverse of 1 by s plus tau s plus 1 is this 1 minus e power minus t by tau. This is minus t by tau is the power of this exponential 1 minus e power minus t by tau. So this is known as step response equation. So when you give a step step input of magnitude m in m, the response for this is going to be mk into 1 minus e power minus t by tau. Now, if you substitute t equal to tau, sorry, if you substitute t equal to infinity in this, as t tends to infinity, substitute t equal to infinity in this, what will be the value of this equation? This value of the equation will be yt will be equal to mk. This term becomes 0. So yt equal to mk. And at infinity, or yt by mk equal to 1. As t tends to infinity, yt by mk equal to 1. So this is known as ultimate value. What happens ultimately after infinite time? After infinite time, what happens? What happens after infinite time? This y of t equals to mk, or y of t by mk equal to 1. So what is the meaning of this 1? That which it attains and as an ultimate value. Now let us consider I am giving a step input of magnitude 1 to a first order system. Let me take an example of thermometer. Thermometer example of first order system. For thermometer, K equal to 1. And if I give a unit step input, M equal to 1. So this x of t becomes what? X of t becomes 1. This x of t becomes 1. That is, you're changing the input by a magnitude of 1. If you give a unit step input to thermometer, if you give a unit step input, that means you're changing the input to the thermometer by magnitude of 1. And thermometer K equal to 1. So what happens? What happens to the ultimate value of the response? This means yt also equal to 1. Since m and k are equal to 1, yt also equal to 1. That is, when you give a magnitude, when you change the magnitude of the input by 1, the same change in magnitude occurs in the response, same change in magnitude 1 occurs in the response when t equal to infinity. When t equal to infinity, the same change in response, the change in response equals the change in the input. So to reach 100% of the change in input, for the response to reach 100% of the change in input, it takes infinite time. It takes infinite time. That's what it takes infinite time to reach 100% of the change in input. I hope it is clear. It takes infinite time to reach 100% of the input. Suppose you change the thermometer environment. That is, for example, the environment of a thermometer is, say, the surrounding temperature. You change the temperature of the surroundings by 1 degree, then the thermometer reading also should change by 1 degree. But not when. Is it immediate? No, takes place at infinite time. So it takes infinite time theoretically for the thermometer, for any first order system to respond 100% to the change in the input value. So this is what it means. But what happens before infinite time? Infinite time is practically not possible. What happens after t equal to 0? T equal to 0 is the time at which disturbance occurs. So beyond t equal to 0, up to between infinity and 0, between 0 and infinity, what happens to the response? That is the dynamic nature of the response. That's the dynamic behavior of the response. That is indicated by this equation, step response equation. So this equation tells us, step response equation, this equation tells us what will be the dynamic nature of response between 0 and t. At t equal to infinity, already we have the value, numerical value. At other times, between 0 and infinity, represented by this equation. What are its features? How will it behave? From t equal to 0 onwards, how is this equation going to behave? What are the other features? So we'll see in the next lecture. These are the important features. What happens to the dynamic behavior of this first order system after a step input is given? So that dynamic behavior in between transient response, the transient response has some important features which we'll see in the next lectures. See you.